I am Balaji Rao. Welcome to BR Max class. Till now, we completed 43 problems on domain of a function video series. In this class, I am going to do another 5 problems. Whatever the problems we will do today, in all the problems, we are doing domain of a function involving with inverse trigonometric functions. Before going to start this video, please drop a like, which gives me more energy to create many videos. And without much delay, let's begin the class. We need to calculate domain of square root of sin x. You can observe two things here. One is square root, another one is inverse trigonometric function. To calculate domain of this function, whatever the expression is there in under root, that must be greater than or equal to 0. This we learned in previous classes also. And second point, here sin inverse x is there. Na? What is the domain of sin inverse x? In last class, we learned that domain of sin inverse x is closed interval -1, 1. So here whatever x value is there, that must be in between -1 and +1. Otherwise the sin inverse x is not defined. So -1 less than or equal to x less than or equal to 1. Okay. Now I need to find the x values which satisfies both inequalities. For this I'll apply sin on both sides. We know that sin of sin inverse x is x. Sin of sin inverse x is x greater than or equal to sin 0. We know from trigonometry table sin 0 is 0 and -1 less than or equal to x less than or equal to 1. Now what are the x values which satisfies both the conditions? You observe here x greater than or equal to 0. In this you can observe that closed interval 0 to 1 is there in this interval. Closed interval 0 to 1, yes, it is there in this. Closed interval 0 to 1 is there in this, yes, it is there. So when I do their intersection, what I'll get? I'll get its domain. What is the domain of given function? Intersection of these two is closed interval 0 to 1, closed one. 0 is included in both, 1 is also included in both. So domain of root over sin inverse x is closed interval 0, 1. You observe this question number 45. We need to calculate domain of this function. Here three things are there. One is square root, second one sin inverse trigonometric function, third one is log. So to calculate domain of this function, we know that whatever the expression is there in under root, that must be greater than or equal to 0. It means sin inverse of log x base 3. This value must be greater than or equal to 0 because this expression is in under root. Second one, we know that sin inverse x domain is closed interval -1, 1. This log x base 3 lies in between -1 and +1. -1 +1 both are included. And you see log x, logarithm is defined for positive real numbers only. So whatever x we will write here, that must be greater than 0. Now we need to find the x values which satisfies all three conditions. First, what I'll do, I'll apply sin to this on both sides. Sin of sin inverse x is x. So what I'll get here? Here I'll get log x base 3 is greater than or equal to sin 0. We know that sin 0 is 0. Okay. Further, if I simplify this, as per the definition of logarithm, this can be written as x greater than or equal to 3 power 0. 3 power 0. 3 power 0 is 1. I am using logarithm definition here. And one important point, in the base, if the number is in between 0 and 1, when I use this logarithm, at that time inequality changes. As this base is greater than 1, when I take this side 3 power 0, this inequality remains same only. So x greater than or equal to 1. Now come to this. Here again I am going to use logarithm definition. I will take 3 to this side. As this number is greater than 1, when I take this to this side, inequalities remain same. So what you will get? 3 power -1. 3 power -1 is nothing but 1 by 3 less than or equal to, here x will be there, less than or equal to 3 power 1 is 3. And the third condition is what? Third condition is x greater than 0. Now to identify the x values which satisfies all three conditions, you can mark this on the number line, but this is easy only. By observing all these three inequalities, directly we can say. You observe in this closed interval 1 to 3 is there. In this closed interval 1 to 3 is there. 1 is included because equality. Greater than or equal to 1, 3 is also included. You observe in this closed interval 1 to 3 is there. 1 by 3 means 0.3 na, 0.33 something you will get here. That means closed interval 1 to 3 is there in this. In this closed interval 1 to 3 is there. X is greater than 0 means closed interval 1 to 3 is there in this also. So what are the x values? X belongs to closed interval 1 to 3. If I do the intersection of all these, I'll get this. So this is domain of this function. If I take any x value in this interval, this function is defined. That's why this is called domain of this function. What is domain of the function? Finding domain of a function is nothing but finding the values of x for which given function is defined. You observe this question number 46, domain of tan inverse of 5x. What is domain of tan inverse of x? Domain of tan inverse of x is all real numbers. So whatever the expression is there, it must be any real number. 5x is a real number because tan inverse x domain is all real numbers. Now whatever expression is there, it must be a real number. As 5x is a real number, x is a real number or not? Yes. If 5x is a real number, then x is a real number. So this function is defined for all real numbers. This is very easy question. Not only tan inverse of 5x. Suppose they given tan inverse of 3x. What is the domain of tan inverse of 3x? Domain of tan inverse of 3x is all real numbers. So domain is all real numbers. This all real numbers you can write like this, or else all the numbers in between minus infinity to plus infinity. This is also represents real numbers. You can write like this or you can write like this also. So domain of tan inverse of 5x is all real numbers. You observe this question number 47, domain of sine inverse of x square by 2. We know that sine inverse x is defined when x value lies in closed interval minus 1 comma 1. So here this x square by 2 value must lies in between minus 1 and plus 1. Then only the sine inverse of x square by 2 is defined. Now I need to find the x values for which this inequality holds good. As what I'll do here, to get x values, I'll multiply this complete inequality with 2. As 2 is a positive real number, this inequality remains same. Multiply this complete inequality with 2. Minus 2 less than or equal to, when I multiply here with 2, 2 will get cancelled. X square less than or equal to 2. Now I got like this, minus 2 less than or equal to x square less than or equal to 2. You observe here, x square is always positive, there is a chance of 0. So x square values will never be negative. So further I can simplify this little bit. How? 0 less than or equal to x square less than or equal to 2. X square value possibility of 0 or more than 0, but it never be negative. Now I need to find the x values which satisfies this condition. If x is there here, then I can do this problem very easily with the help of wavy curve method. But here x square is there, no problem. We can do it. See here, 0 less than or equal to x means x square greater than or equal to 0. 0 less than or equal to x square means x square greater than or equal to 0. And what is the other one? X square less than or equal to 2. X square less than or equal to 2. Take that 2 to this side. X square minus 2 less than or equal to 0. Now x square greater than or equal to 0. For what x values x square is greater than or equal to 0? You can take x is any real number. You take x is any real number which will be greater than 0 or equal to 0. What are the x values satisfying this inequality? Any real number satisfies this inequality. Okay. And you observe here 2 is there. This 2 can be written as root 2 whole square. 2 can be written as root 2 whole square. Now it is in the form of a square minus b square. What is the formula for a square minus b square? X plus root 2 into x minus root 2 less than or equal to 0. You observe this. This is in the form of x minus a into x minus b. By using wavy curve method, I can easily calculate for what x values this inequality holds good. Now you equate this to 0, you will get x equal to minus root 2. You equate this to 0, you will get x equal to root 2. To calculate x values which satisfies this inequality by using wavy curve method, in the rightmost corner you write plus and then alternate symbols minus plus. Less than or equal to 0. Less than or equal to 0 means I need negative values. This what are the x values satisfies this inequality? Negative sign is there here. X belongs to closed interval. Why closed interval? Because here equality is there. Closed interval minus root 2 comma root 2. So these are the x values which satisfies this inequality. I need the x values which satisfies this condition and this condition. You can observe that this set is a subset of this set. When A is subset of B, then A intersection B is A only. Smaller set we will get. This is the smaller set. This is the subset of this. When I do their intersection, you will get this only. So domain of this function is what? Closed interval minus root 2 comma root 2. So whenever whatever x value you take in this interval, then this function is defined. That's why this is known as domain of the function. You observe this question number 48. We need to calculate domain of this function, sine inverse of log x by 3 base 3. We know that domain of sin inverse x is closed interval minus 1 comma 1. So this value lies in closed interval minus 1 comma 1. That I'll write like this: minus 1 less than or equal to logarithm of x by 3 base 3 less than or equal to 1. And one more thing, here you observe here log is there. We know that logarithm is defined for positive real numbers only. So whatever this expression is there, that must be greater than 0. So x by 3 is greater than 0. Now I need to find the x values which satisfies both inequalities. Here logarithm is there na, directly I will apply logarithm definition. In the base this value is greater than 1 na, so when I apply logarithm definition this inequality remains same. When this base value is in between 0 and 1, at that time inequality changes. Okay, you take 3 to this side, 3 power minus 1. 3 power minus 1 is what? 1 by 3 less than or equal to x by 3 less than or equal to 3 power 1. 3 power 1 is 3. Now what I will do to get the x values, I will multiply this complete inequality with 3. Multiply this complete inequality with 3. 3 into 1 by 3, that is 1 less than or equal to 3 into x by 3, that is x less than or equal to 3 into 3 is 9. So these are the x values which satisfies this inequality. You come to this, and one more thing is there here, x by 3 greater than 0 means what is x? You take 3 to that side, x is greater than 0. So I need the x values which satisfies both the conditions. Closed interval 1 to 9 is a subset of this. As this is a subset of this, when I do their intersection, I will get the smaller set. So what is the intersection of these two sets? Intersection of these two sets is the domain, and the domain is closed interval 1 comma 9. Or else simply you can say this is the domain of this function. Whenever I take x values in this interval, this function is defined. That's why this is known as domain of this function. What is domain of a function? You always keep this in your mind. Finding domain of a function is nothing but finding the values of x for which the function is defined. Dear friends, please drop a like to this video. It gives me more energy to create many videos, and share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Have a great day. Bye bye.